Hi guys, welcome to this set of videos. What we're going to do here in this set of videos and this section of notes is we're going to talk about ways that you can show that two triangles are similar. Now, let's say, for example, that I don't tell you, right, that they're similar. In previous sections, we've looked at I tell you that figures are similar and what we can do with those. But what if I don't tell you that they're similar? How can you show that they are? Well, let me sort of run you back to a previous chapter. Earlier here in geometry, we did some work with proving that triangles were congruent. And when we did that section on triangle congruence, we talked about a theorem known as Cpctc. Cpctc, which simply means that corresponding parts of congruent triangles are congruent. But remember the amount of work that was. In order to use Cpctc, you had to prove that all three corresponding angles were congruent, and you had to prove that all three corresponding sides of the triangles were congruent, which meant that you had to prove 6 things. And that's a lot of work. I don't know about you, but I prefer not to work so hard. And so what we did was we then began to look at some shortcuts. Right? Are there faster ways to prove that triangles are congruent? And we learned some theorems like the side-angle-side theorem, or the side-side-side theorem, or the angle-side-angle theorem. And what that did, those theorems cut our work in half. Instead of having to prove 3 congruent angles and 3 congruent sides, I only had to prove, right? Let's say it was side, side, angle, side. So I only had to prove that 2 corresponding sides were congruent and that the included angle. Well, that's only 3 things, which should take half as long, right? So what those theorems did was they saved us some time. Okay, so now we come here to similar figures. Well, think about what we've been doing. In order to show that figures were similar, we first had to show that all of the corresponding angles were the same. And depending on the figure, that could be a lot of work, right? We even looked at a couple of figures where we had pentagons. That means you've got 5 different angles, right? And you have to prove that 5 different corresponding angles are congruent. And already, that's 5 different things that you got to prove. That's a lot of work. Not to mention then that a pentagram also has 5 sides. So there you are, you're proving 10 different things just to do one problem. We want a shortcut if there is one. And it turns out that for triangles, there are some shortcuts. So let's go ahead and take a look at those shortcuts. The first one we're going to talk about, actually, I'm getting ahead of myself. So how can we show that 2 triangles are similar? There are some shortcuts. Instead of having to prove 3 angles, 3 corresponding angles are congruent, and showing that the ratio of the lengths of corresponding sides for 3 sides are all the same, we've got some shortcuts, and here they are. So students will show that triangles are similar using the AA, the SSS, and the SAS triangle similarity theorems. We'll talk about what each one is and get some practice with each of those. Then, once you can tell me that the figures are similar, we're going to do some algebra. Find unknown lengths and angle measures. Now, in the last section, the section we just did, we did that algebra. We set those angles equal to each other and solve for the unknown. We set up those proportions and solve for the unknown. But in those problems, I told you that the figures were similar. What you're now going to do in these problems is use these new theorems we're going to talk about to first, on your own, determine, are these figures similar or are they not? Then, if they are similar, go ahead and set up those algebra problems and solve. Oh, I can't wait. Here we go. Let's take a look at this. The first one, angle, angle, triangle, similarity. All right, here's why this theorem makes perfect sense, guys. It makes perfect sense. What do we already know about similar figures? Well, we already know that similar figures, all of the angles have to be congruent. Remember, similar figures are the same shape. And if you change the measure of the angles, you change the shape of the figure. So, similar figures, whether you got a small triangle and a large triangle, the angle measures have to be the same. So then you may be thinking to yourself, well then why isn't it the angle, angle, angle similarity theorem? Haha, fantastic. Again, remember back to a previous chapter where we learned the triangle sum theorem. Remember, in a triangle, the internal angles must sum to 180 degrees. All three angles have to sum to 180. Well, if you know, right, if you got two different triangles and you know that two of the angles in both of those triangles are congruent, what do you know about the third pair of angles? They have to be the same because all three angles have to sum to 180 degrees in both triangles. If they don't, you don't have a triangle. So again, saving ourselves some work. Using the triangle sum theorem, we don't have to prove that all three angles are congruent. We only have to show that two angles are congruent. So let's take a look at how this works. First, I want you to prove the triangles are similar. I've given you a diagram here, but I tell you nothing about those triangles being similar. So you have to determine, are they or are they not? Then, if they are similar, right, if possible, if they're similar, find the unknown measure. But before I can find the unknown measure, I gotta know, are these triangles similar? Because they're clearly not congruent, right? One triangle is definitely smaller than the other, but are they similar? Well, let's find out. Again, in order to apply the angle-angle theorem, I have to be able to prove that two corresponding angles are congruent, and here's an easy one. Going back to a previous chapter, I know that vertical angles must be congruent. So angle B is of course congruent to angle B. There's one angle. I only need one more. I just need one more. Well, look at this. Hopefully you noticed looking at the diagram, I gave you these little arrows right here. Do you guys remember what those little arrows mean? Yeah, those arrows tell you that line AC and ED are parallel lines. And once again, pulling from a previous chapter, I have parallel lines cut by a transversal. So what have I got? I have alternate interior angles. Angle C and angle E must be congruent. They have to be, right? That's the alternate interior angle theorem from, I believe it was chapter 4, at least in our book, chapter 4, if you're taking this class with me. We talked about parallel lines cut by a transversal. Well, I got parallel lines, they're cut by a transversal, which means C and E are alternate interior angles. And they have to have the same measure. They have to. So there you go. Angle, angle, triangle similarity theorem. So I have angle, angle, similarity. Boom. Let's find our unknown measure. Okay, here we go. Erase, 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 erase. What am I looking for? Well, I want to find BE. All right, right here. There's BE. All right, so BE corresponds with which side? Well, I know that BE corresponds with, right, if I take this triangle, rotate it so that it lines up with the other one, it corresponds with side BC. All right, and that because the triangles are similar, I just proved they're similar using the angle-angle triangle similarity theorem, they are similar triangles, I know that that ratio has to be equal to, well, look at this, BD and AB. So there we go. BD and AB. This point, guys, plug and chug. I'm trying to solve for BE. I know that BC is 54. Let's see, I know that BD is also 54. Interesting. And AB is 36. Hey, let's, actually this is, you'd be tempted here to cross multiply, but actually you're doing more work than you need to. I just need to get this BE by itself. Since I have division by 54, just multiply the 54 to the other side. All right. Throw that into a calculator. Don't fat finger something on your calculator. 54 times 54 divided by 36, I get 81. And there you go. You found the unknown length, right? Because I didn't know BE. I asked you to find BE, and you were able to prove that the figures were similar. Well, you actually had to prove the figures were similar first. Then you could set up your proportions to solve for the unknown length. That's the way that these problems are going to go. Head on over to the next page of notes. I got a few more for us to try together. I'll meet you there.